Alright, this should be our last video for the test 6 review. Let's go ahead and get started. We're graphing here. So notice it says be sure to first graph the parent function and include the appropriate asymptotes. Remember, the asymptotes are a key feature of these graphs. So first of all, on 21, our parent function is going to have a base of 5, so it would be 5 to the x power. And we learned with exponential functions, it's really easy to plug in x values and solve for y. We're just taking powers of 5. And it turned out that using -1, 0, and 1 turned out to be really nice, because 5 to the 0 power is 1. So the y-intercept is a key point on these graphs. And then we just want to find an x value on each, or a point using an x value on each side of x equals 0. So if we plug in 1, 5 to the 1 power is 5. 5 to the 0 power would be 1. And 5 to the negative 1 power would be 1/5. Now we also know that these two numbers here are always going to be reciprocals. So that makes this go pretty fast. So let's go ahead and put those points on the graph. And I'm going to go ahead and make a dotted line of this graph and put in my asymptote here. So it looks like that. So that's the parent function in this problem. So now if you see the 5 to the x minus 2, we know the minus 2 there is going to cause us to have a horizontal shift 2 to the right. So the reason why is because the minus 2 is with the x in the exponent. That's going to cause a horizontal shift. These are the ones that are backwards. You might have thought you should go left 2, but we actually go right 2. Now the minus 3 is totally separate from the other part of the function, and so that causes a vertical shift down 3. And these are pretty straightforward. If it's minus 3, we're going down 3, which is what we would expect. So we're going to move each of our 3 points on the parent function right 2 and down 3. So when you do that, you get these 3 points here. Now, when I go to the right 2, my asymptote won't change when we move right or left. But because we're going down 3, the asymptote's going to go down 3. And so the graph looks like that. Our domain for exponential functions is always going to be all real numbers. Our range, well, let's see, it's going to go from -3 to infinity here. And the asymptote is y is equal to -3. All right, let's look at 22. So the parent function here is 1/3 to the x power. And so we'll do the same thing we did last time. 1/3 to the 1 power is 1/3. 1/3 to the 0 power is 1. And we know that this should be the reciprocal of the 1/3 there, so that's 3. Let's go ahead and plot these points and draw the asymptote. Remember, our parent function with exponential functions is always going to have a horizontal asymptote at y equals 0. All right, so now we need to look at the transformations we need to make, or the shifts or reflections. Notice, because of this minus out front, we're going to have, oh, I'm sorry, I didn't finish drawing my graph there. So we're going to have a reflection through the x-axis, and excuse me, because of the +2, where everything's going to be moved up 2 or shifted up 2. So we always do reflections first. So let's reflect our 3 points. So you reflect them through the x-axis, and those are the 3 points that you get when you reflect the 3 points at the top through the x-axis. So for example, this point here is up 3 above, at -1 we're up 3, so we're going to be down 3 when x is -1. So that's how you do the reflection there, and so that graph looks like that. Notice the asymptote didn't change, it's still y equals 0. But now we're going to move all 3 of our points up 2 By the way, that's the graph of minus 1/3 to the x power. So move each of your points up 3. Notice when you do that, the asymptote's also going to move up 2, and your graph's going to look like that. The domain, again, is all real numbers, as it always will be with exponential functions. Excuse me. The range, let's see, we don't have a lowest point, but we don't quite get to 2. And the asymptote here is y is equal to 2. All right, on the next slide, we've got 2 more to do here. But now we're graphing logarithmic functions. So on the first one there, let's see, the parent function would be the log base 4 of x, since it's a base 4 log. And I'm going to switch, well, it can be difficult to pick x values for log functions. So I'm going to switch to the exponential form. And when we make our table, notice this time the variable is y in the exponent. And so it's actually easier to pick our exponent values. So we're going to choose y to be -1, 0, and 1. And so notice it's the opposite of what we do with exponential functions. If we plug a 1 in for y before the 1 power, that's 4. 4 to the 0 power, that would be 1. And 4 to the -1 power is 1/4. But again, we know these two numbers are always going to be reciprocals. So let's go ahead and plot those points. And don't forget to put your asymptote in. Notice it's a vertical asymptote at x equals 0. So now we can look at the shifts here. I'm just going to fill that line in there. So because of the +3 there, we're going to go right. Because of the +1, we're going to go up 1. So just move each of these 3 points up 1 and right 3, or right 3 up 1. It doesn't matter which order. And you get those 3 points there. Now, when you move right 3, notice the asymptote's going to move right 3. When you move up 1, that's not going to affect the asymptote at all. So we need to put our asymptote right 3, and then there's the graph. So the domain goes from 3 to infinity. Remember, we go left to right, looking at x values, and then the range, lowest to highest, with the logarithmic functions, it's always going to be all real numbers. You can see that here. You can see that it's important that you draw that part of your graph correctly. If you made it look like it was leveling off or going down, you might be tempted to think your domain were different. So be careful how you graph that. The domain with logarithmic functions is always going to be all real numbers. All right. Asymptote. Notice that would be x equals 3. All right, at number 24, our parent function is y equals log base 2 of x. So again, let's switch to the exponential form, and let's make a table where we choose y to be -1, 0, and 1. And so here we're going to get 2 when we let y be 1. If you let y be 0, you get x equals 2 to the 0 power, which is 1. And of course, we should get the reciprocal there. So when you plot those points, it looks like that. And that's your parent function. And in fact, this is the graph that I want you to think of when you think of a logarithmic function. Normally, our base is going to be greater than 1. Or, yeah, it'll be greater than 1, and so the graph's going to go through 1, 0. It's going to be increasing, and so this is the shape, and this is the asymptote we get, x equals 0, when we're dealing with logarithmic functions. So in terms of our shifts, notice first of all we have a reflection through the x-axis, and we need to move everything right too. So we know that we always reflect first, so let's go ahead and do that. So again, this point is up 1, so I had to go down 1 to put that point across the x-axis. And so the graph looks like that. And then we need to move each of those 3 points 2 to the right. And if we're going 2 to the right, the asymptote's also going to move 2 to the right. And so you get that graph there. And so the domain is 2 to infinity. The range is all real numbers, which it will always be with logarithms. And the asymptote, you can see, is x is equal to 2. All right, let's move to the last page. We got 2 slides to get through that last page. We're basically doing what we just did kind of backwards. We don't actually have to do any graphing here. So we have f of x equals 6 to the x power. If we shift that 1 unit right and down 5 units, what's going to be our new equation? Well, let me go ahead and get this set up. We know it's going to be x, if we're going right 1 unit, we're going to put x minus 1 in for our exponent. That'll cause a shift right 1, which is what we're supposed to have. And then down 5 units, that would be minus 5. Now remember, with exponential functions, y equals 0 is your asymptote, and it's only when you go up or down that that's going to change. When we go down 5, that moves it down 5, so it's going to be at y equals negative 5. Now if you have a problem doing this, you may have to draw a little sketch to help remember what happens to your asymptote. All right, on number 26, it says if 4 to the x were reflected about the y-axis, then shifted 5 units up. Well, let's see. Reflected about the y-axis, that means we need to put the minus with the x as opposed to putting it out front. So we're going to have 4 to the minus x, and 5 units up, that's going to be plus 5. So again, this is a horizontal asymptote at y equals 0 for the parent function. And the only thing that's going to change that is if we go up or down. And so we're going up 5, so it'll be at y equals 5. All right, let's move to our last slide. So here we have the log base 7 of x. And it needs to be shifted 2 to the left and down 4 units. So let me go ahead and get this set up. So since we're going left 2, that's going to be plus 2. That would cause a horizontal shift left 2. And then down 4, that'll be a minus 4. So with log functions, the asymptote is at x equals 0. And it's only going to change if you move to the right or the left, or if you have a horizontal shift. So when we go 2 to the left, that causes the asymptote to be at x equals negative 2. Again, when you take your test, you may have to, or you may want to actually draw a little sketch, if that'll help. All right, on 28, let's go ahead and get this set up. So we want to, now this is a reflection through the x-axis, and wait a second here. Okay, so we do have a reflection here, so I actually need to put a negative, hold on just a second, in front of the log, and then shifted 5 units to the right, so that's going to be a minus 5 there. Whoops, let me not do that. And then up 2 units, so we'll add 2. And so that would be like that. Now again, it's only when we go right or left that we're going to change the asymptote. So moving 5 to the right, our asymptote's going to be at x equals 5. And that's the end of this video.